Aha. I think we're live. Oh, we've got a viewer. Okay, right. I'm a bit late starting today. But oh, thanks for the like, whoever liked the video straight away. Okay, so I think we might as well start. We're a bit late, but so be it. So basically, what I think we're going to do today is I was messing around with Sapling, and I realized that there's a crash bug. And in the README, I said crashes are just like not allowed. If Sapling crashes, that's a critical bug as far as I'm concerned, and it needs to be fixed. So that's what we're going to do today. I've made an issue. Where are we? And then if we switch over to Firefox, oh, not here. I've made an issue half an hour ago with this, which is, you can look at if you want, but it's not super interesting. It just describes what we're doing. And hopefully that we'll make a pull request that closes that today. Let's switch back to code. Okay, right. So what's the bug? Well, let's check out master. I don't think it's specific to the syntax highlighting branch. So suppose we run Sapling, and it's surprisingly easy to get this to happen, actually. So all we need to do is to move to the first child, delete some stuff. So we delete all of the children, undo, and then redo, and Sapling crashes. Okay, which is dumb, because like that's obviously shouldn't happen, because undoing and then redoing, you should get back to the same state, and the state is not crashed. So this is bad. And Rust does tell us something. It says cursor path points to a non-existent node. That's it. And I'm not 100% sure why this is actually happening. So this will be a bit of a voyage of discovery for everyone. I have an idea for why it's happening, and I think it's just like the code is not very well written, and therefore, so one specific part of the code causes this to happen. And basically, what is happening? Oh wait, I don't have the ability to draw. Hold on, let's get the ability to draw. I should have set this up to start with. Oh well. Create new 1000 by 800 or something like that. Let's create a new canvas. Oh, yay, OBS has accepted that. Okay. So, oh no, that's too big. That is way too big. That's kind of too small. Okay. So pretty much what I think is happening is that Sapling stores, how should I explain this? Okay, let's do this by example. So pretty much the idea behind Sapling's undo redo system is that pretty much there's a question in text editors, which I think is fairly open. There's not one objectively right way to do this. But it's what should happen if you make a change, move the cursor somewhere else, like you move it here, and then undo again. Do you attempt to leave the cursor in the same place and then undo something potentially way off the screen, right? Or do you, by undoing, move the cursor to where to where the edit was? And that's what Sapling implements. So if we undo from this point, we removed a node in here. Oh wait, you can't see this. No, wrong thing. IDE. Okay, let's do this again. So suppose that I make an edit somewhere. I remove true, and then I go somewhere else, say this. And now I undo. Like what should Sapling, or what should any text editor do in this case? And I think you basically got two options. You can move the cursor or leave it where it is. And I think that moving the cursor is just way more logical. So in this case, if you undo... Huh. That was not what I expected. Okay, so what I was expecting it was that Sapling would move the cursor back to the node that we created. Okay, which is where the cursor was just before the edit happened. So what I was expecting to happen was this, then we move a bit, and then we undo and be back here. Which is, interestingly, not what's happening. That's another bug. We should track that down, actually. Where is this bug happening? So this has to be in editable tree, because this is to do with undo and redo. Oh, actually, I think it's to do with finish edit, which is here. So, what? Okay, so pretty much what Sapling is supposed to do is it's supposed to save, in the undo history, it's supposed to save the cursor locations as it edits. Where is this undo? Oh yeah, here we go. So we have root history, which is kind of actually a bad name now that it stores roots and cursor paths. But basically, this is where the history is stored. Because nodes are... so Sapling doesn't store edits as edits and then an action to undo the edit. Sapling does what Git does. So if you imagine so for those who don't know how Git works, Git is basically version control, and Git is an application that stores a whole load of snapshots of your code. And this is important because in order to step back in time, all you have to do is to move back to that snapshot. All of the tree is just still there. In Git's case, the tree is a file system, and Git's trying to just like look at changes over time. In Sapling's case, Sapling is storing syntax trees of the program, and the edits are edits that the user is making all the time. But the principle still holds, that the edits should, that the principles of Git should work with Sapling. And so this is essentially a commit. So one step in the root history is kind of analogous to a commit in Git. So we have a node, which is kind of a pointer to like, here's the root of the tree. And then you end up with a whole load of like pointers into roots, all of which like have trees coming down from them. And then undoing and redoing is really fast, because all you're doing is just updating a pointer to say, oh yeah, this is the current root, and then update the screen, and it just updates everything, and now it just renders this tree. Of course, you can deduplicate the tree, right? You can. There'll be lots of duplication between those, because you're not deleting everything and starting again all the time. And Sapling handles that. But fundamentally, it's storing a whole load of changes as complete syntax trees, which may be the wrong decision. We may find that. But anyway, that's how it's implemented for now. But along with that, it also stores where the cursor is for that edit, which is important because, like, what I was expecting Sapling to do is to move the cursor back to the location of the edit, which it kind of does, right? It moves the cursor, but it kind of misses the location of the edit, which is actually a bug. And I'm pretty sure this is sort of the bug that's causing the crash that we saw, which is that, yeah, if we do this and then redo it, crashes. So, like, there are only so many places this code can be, this error can come from, because this root history is only actually edited in one place, I think. It's only modified in one function. if we just search for it. Okay, it's initialized when the thing gets initialized. That's logical. Oh, it's used to get the root of the tree. Yeah, obviously. And then undo and redo, obviously both edit the root history, because they're going to have to do that. And finish edit edits the root history, because finish edit is called at the end of every time an edit happens, and it's in charge of saving the contents of the tree. So it's kind of logical, and we're back to the start. So the bug must be happening in one of these three functions, is basically what we know now. This is about as far as I got before this, like when I was just looking at this in the hour or so before the stream. And I was fiddling with something else, actually. And I also, there's something else that I don't like, which I think we can fix at the same time, which is that a lot of the action code is very repetitive. So if we look at inserting a child and inserting next to cursor, so, oops, this is insert child, and then down here we've got insert next to cursor. We can see that it does largely the same stuff. It caches some things and does some checks to see whether or not the insert could even happen. And then all of this code actually is the same, right? It creates some nodes to clone and then does some stuff, which is this stuff, which will be different for every edit. And then it finishes an edit and returns a success. And this happens every single time, right? You can see we cache some things, and then we perform the edit. So we check the edit is safe and won't mess up the tree somehow. Then we make this nodes to clone thing, and this is literally the same lines of code as up there. And then in this case, we do something different. We remove something, and this is because the edit nodes to clone is a complete descent down the tree, down to the cursor. But inserting next to the cursor doesn't actually modify the node underneath the cursor, it modifies the parent of that, right? Because we're adding children to that. That doesn't modify the cursor, it only modifies the parent. So we don't actually need the cursor, which is why we pop it. And the descent down to the cursor, the last step in that chain is the cursor, so we remove it. And then we actually perform the insertion. Then we call finish edit and return. And I'm pretty sure this is, and finish edit is quite finicky. And I was trying to implement some stuff, and it was just like annoying. I'll see if I can explain. What's the thing that's causing the bug? The thing that's causing the bug is this function, is deleting the cursor, because that's what we're actually doing. If we get the crash to happen, we delete the cursor 3 times, then we undo the last delete, and then we redo the last delete, and Sapling crashes. Which is pretty weird, actually. But like, it is something is clearly wrong with the delete. And I'm pretty sure it has to do with the cursor ending up in the wrong location. Because what I can do, when we perform the redo, we can just check, we can get Sapling to say where the cursor is, because that would be a useful thing to debug. This is something I did before, but I did it on a different branch of the edits, and therefore I lost it. Where are we? We're fun redo. So we could say as a debug, log debug setting cursor path 2, and then we just debug the current cursor path. Not sure why the suggestion stopped working. Oh well. And then let's just for so that we know, we can say log.trace performing redo, just so that we can see what's going on, because we really want to log this for undos as well. Because you can imagine a similar situation, maybe with inserts, that would cause a similar crash bug, and we might want to find this. So we do the same thing, and then we say performing redo. No, performing undo. Obviously these two won't be used, but we set them there anyway. So now if we get the same thing to happen, then we see we get redoing one change. Oh, that's, yeah. So we see that we've got, the traces don't log by default, because you would kind of expect one trace per function. So we don't log by trace by default, but we can see that we're setting the cursor path to some cursor path with child indices 0. And I haven't really explained how cursor paths work, I think. There's been a bit of confusion with people making pull requests about what's actually going on. And pretty much cursor path is fairly simple. So imagine we have a tree, and I'm not even, it doesn't even matter what stuff there is in it. It's just a tree with some things. And I suppose it's a fairly interesting tree. It has some children in it. Let's say we have a fourth thing, and it has a child which has some children. A cursor path is just a way of specifying a location inside the tree that isn't dependent on exactly what the memory layout is, right? Because obviously all of these nodes would exist in memory somewhere. Oh wait, you can't see this. You can't see this. Help. Where's my thing? Here we go. Okay, so I've just made a tree, and you can imagine that what we're going to have is we're going to have some tree, and we want to specify the location of a node. Let's say we want to specify this one. And we want to do it in such a way that if we were to edit this tree, which remember in Sapling corresponds to rebuilding the entire tree again. So if you were to make an edit here, then, so we edit this node, then this node would get replaced, this node would get replaced, and the root would get replaced. I can't draw. So we really don't want to store pointers into this, is what I'm saying. Because suppose we were storing the pointer into this location, and we expected that to work. Well, clearly it wouldn't, because as soon as we make an edit further down the tree, these nodes would get replaced, and now we're pointed to an old change. So the way we get around this is to, instead of storing direct pointers, we store a list of instructions for how to walk down the tree to get there. So for example, the root has no path because we start at the root. So the root has the empty list as its path. This has singleton 0 as its path, because we have one instruction, which is say start at the root, then move to the 0th child. Remember, programming languages are 0 indexed by default. Rust is anyway. So this is index 0, and then this one will be 0, 0. So it's the 0th child of the 0th child of the root. And then same here, this would be 1, and then, that's weird, 0, sorry, 1, 0, etc. And just for the sake of an example, let's just go to this one, because it's more interesting. This is 3, this is 3, 0, because it's the 0th child of the 3rd node. And then this will be 3, 0, 2. And importantly, this is the same. If we were to make an edit and all of these nodes were to get replaced, so long as the root pointer still updates, then 302 will still point to the correct location. It won't point to the same node, potentially, because we could replace it with something else. But we still point to the same index. Okay, but suppose that we had the index, the path 2, 0. Right? Well, what node would that be? because so obviously 2 is this one. This is 2. But what's 2, 0, right? There isn't a child. So 2, 0 is technically valid. Like this should be a valid cursor path, but it isn't, because it actually there isn't a node that has it. And this is actually the error we're getting. If we look at the cursor path code, editable tree. Come on. Oh yeah. Hold on, you can't see this IDE view. If we go to editable tree, no, is it cursor path? Yeah. So we go to the cursor path, and then so we have an iterator that this iterator here is the iterator that's responsible for allowing us to step down the tree in that way. And we can see here that it says what's the next descendant after the one we're currently pointing at. So here we've got node is a pointer to the current node, and that gets updated every time. And then we have iter, which is an iterator over the indices. So that's just the list, basically, that we're reading through. And then in order to get the next one, we say, oh yeah, well, we have a node. So we get ourselves, what node are we pointing at? Get its children, and then look up the next index, and then get that child within, so we get that. Okay, yeah, no, so kind of rambling. Okay, so what we're doing is we're getting the next child index, and then getting that index of the node we're pointing at. So this would hopefully give us a raw, like, it would actually give us a pointer to the next node. And then, but this could fail, like we could be out of bounds. In our example, we could have something like the path. So this fails. We can have a nice red color to show that. This is invalid. And let's get black. We could have something like 4, just the 4th child of the root. And obviously this is also invalid, because the 4th child of the root doesn't exist. It's like, well, what's here? Clearly, nothing's here. Hold on. Is that blue? Why? ABS, why do you flip the red and blue channels around? That's so bizarre. Hold on. Let's fix that. Where are we? Properties. No, we want to be this. And swap red and blue. Boom. Okay. Right. So now that OBS is actually behaving itself, we can actually get on with some drawing, which is to say that this should be invalid. And it's kind of invalid in a really unsafe way, which is that Sapling really relies on cursor paths pointing to correct locations. If it doesn't, then the whole thing is just broken. And so what I decided was that if we do end up in this kind of situation where a cursor path can't be reached, the cursor path doesn't point anywhere, then we should just crash, which is what's happening in this line. Let's just switch the code. This line where we say if the child doesn't exist, then we crash and say, oh, this cursor path doesn't points to a non-existent node. And this is the crash message we're getting. You can see it's cursor path doesn't point to an existing node, line 144, which is line 144. So this is precisely where the error is happening. And we can kind of see why it's happening, because we're somehow setting the cursor path to be the first child of the root. But as we saw, if we actually do this, then we're redoing to the change that has nothing, that has the empty The root has no children in the edit we're redoing to. So if we redo it, then it updates the cursor path to the wrong location, and then it crashes because the root has no children, and we're trying to access the 0th one, or the first one in human terms. And I reckon that this is because if we look at what's actually happening when we perform a redo, it's quite simple. We look at the so we basically look up where was the cursor at the edit, and then we just update the cursor path with it. Like this code can't corrupt the cursor path. It's just crazy. The only way it can corrupt the cursor location, whatever, is if the cursor path was set incorrectly. And what change is causing it to be set incorrectly? Well, it's deleting a node, right? Because that was the edit that we're redoing back over. Hold on, is it? Yeah, so hold on, let's see, because moving doesn't create a cursor location. So this doesn't create a new snapshot in the history. Deleting does, so we have not the original snapshot, then we do one undo and we get another snapshot, so we got 2 now. Then we do another delete and we get 3, and then we do a third delete and we get 4 snapshots. And then so we have 4, right? And then we're pointing at this one, which is the most recent one. So we undo, and now we're pointing at this one, but the one that is my pinky finger, the most recent one, does still exist. Sorry, it's the wrong way around for you guys, but whatever. And so when we redo to it, then we set up the cursor path. But this was written, the change was created at the delete, right? So when we delete the node, it creates a new step, a new snapshot, which we're undoing and then redoing back, and it's crashing. So now we know that the broken edit is in delete cursor, right? Something in this block of code is causing the snapshot to be set up, the cursor path to be written to incorrectly, and therefore the things break. So, and I think I know why this is happening, because finish edit involves a walk down to the cursor, because it needs to know which node to clone in order to get a new root of the tree, right? And if we were to move the cursor, particularly if we were to move the cursor up the tree, so change the length of its path, then finish edit would break, because it doesn't know, like, it breaks which nodes you have to step through in order to get this to work. Actually, I guess we could just condition on the fact that this happens, because we only move the cursor up and down if we're deleting the last node, the last remaining child of the cursor's parent. In that case, we pop, and otherwise we shouldn't pop. Maybe this is the best way of fixing it. So I think if we were to put this here, I were to say, instead of the 1 here says, how many nodes above the cursor are you making the edit? Right. So essentially we're saying, for deleting the cursor, we're not actually directly editing the cursor. We're editing the node that's 1 layer above the cursor, and that's the cursor's parent, which is why this is 1. We need this because otherwise it will pointlessly clone the cursor, and that will just have really bad side effects. But what we could say is we could make this if return something. So say let steps above Yeah, okay. So steps above cursor to clone. It's a bit of edit pause above cursor. This is not very easy to read, so we should probably fix this anyway. And then what we're saying is, because we're moving the cursor up, after we do the whole cursor moving thing inside to make sure that the cursor isn't invalid, we need, when we finish the edit, finish edit needs to know, like finish edit can't see the past. It can't see where the cursor was. It only sees where it is after the edit. So if we move the cursor up, then we should, instead of starting the re-stitching one above the cursor, instead we do it from the cursor. So we say edit pos above cursor. And I think this will actually fix the bug. I hope it will. But it won't fix the more obscure weirdnesses that were happening. So I think if we compile and run, yeah, so this is working now. But this feels like a hack. We just were like, where's the code that changes it? Oh, well, we condition on the fact that we broke the code and then just like do a workaround in that specific case. That's very not reliable. And text editors have to be reliable. That's like the one thing you care about. Like if you're working with a text editor, it can't just crash on you, because that could cause you to lose a lot of work. And this doesn't prevent the issues of the cursor teleporting, right? If we delete a node and then move somewhere else and then undo, it moves to the wrong place, which is like really strange. And I'm pretty sure it's the same issue, because it's the same issue about moving we're doing an undo or redo, and the cursor's ending up in the wrong place. Sometimes it's ending up on a non-existent node, so it's ending up too far down the tree, which causes a crash. And sometimes it's too far up the tree, which causes doesn't cause a crash, but it causes the thing to move to the wrong place. So I'd quite like there to be a better way to do this, rather than a slightly hacky move the cursor to a different location. And I think what we could do is we could make finish edit be some like instead of just finish edit, we say have finish edit be also a function that starts the edit. So this would look something like, let's see, we would have, where's finish edit? Let's just jump to it. So what I think we could do is we could say, because a lot of this stuff will happen anyway, right? We need to know the cursor's location, and sometimes its parent. So all of the edits start off with finding the cursor and sometimes its parent. Then we do something and create a new node and maybe return an error. And then we like run all the way down to find the cursor again. So we've done this whole step twice. And then we actually perform the edit. And then we run all the way back up the tree, and which happens inside finish edit. So that's not explicit. And this always happens. So we may as well put this inside one function and have the kind of universal edit function take a closure that's specified inside the specific edit function. And that closure actually does the action. So we could say something like edit or like generic edit. I'm definitely going to rename this, but it takes mute self and a closure, which is like for mute. We're going to have to capture self, I think. And it takes self, and then it needs to take two nodes, which is our arena node. and it's going to return an edit result, which is then going to be passed. And then we do all of this kind of running down the tree to get the cursor kind of stuff. And then, so we know, oh wait, yeah, so the parent, the first argument is going to be the parent, I think, because that's kind of logical. We do parents first and then that. But the parent might not exist. If we're editing the root, which, you know, is entirely possible, then expected comma, what? What are you gibbering about? Oh, impulse unmute. Oh, in fact, this is not even, yeah. So edit func is impl. So happy with this. Oh, cheers. That's cool. I guess it still, will it build? Oh yeah, it will, because this function doesn't do anything and it's not used. So this would be the parent and then this would be the child. So what we would say, what we would kind of do here is we would say let parent, nodes to clone has to have at least one thing. So we say let cursor equal new node. Yeah, so nodes to clone dot last. We don't. Yeah, no. So we can't. It makes no sense to pass a mutable thing because nodes are immutable. But let parent. We can unwrap. Unwrap is safe because nodes to clone must always contain at least the root. And then parent is nodes to clone dot, is there like from index dot get? Okay, now we'll just have to do it nodes to clone dot len -2. And this might fail. And if it does, then we don't worry about that. Oh wait, we'll get underflow. Ooh. There must be a get from last. Could we do this with iter dot reverse dot drop skip? So we skip the last thing and then actually we could do this much more simply. So we could say let iter let mute reverse iter, like reverse node iter. So this is an iterator over the things, and then the child. So cursor is this dot next dot unwrap because we require this to have a next. We ought to fuse this just to make sure that it keeps returning none. Oh wait, no we don't, because we assert that it has at least one step. And then parent is reverse node iter dot next, and then we should say that we drop. Yeah, actually we should probably check that it's okay. Yeah, no, I think it'll be fine to leave that hanging around. And then we call our edit func with self cursor parent. Oh wait, this is going to be mutable self because the edit has to make an edit. We call this here. Oh wait, the arguments are in the wrong order. Yeah, let's just... We want to copy this, right? Because we can copy pointers. Why do I need to copy the closure as mutable? I don't understand. Oh wait, can we just take a mutable thing as an argument? No. And then so after we've made, so now I've made the edit, and then we want to do all this stuff. There we go. Which of this stuff do we actually need? So we need to, we do need to remove the future history that we're never going to go back to because we're making an edit. We could probably... initialize. So we're pretty much initializing the edit, and then we're performing whatever edit was specified, and then we're cleaning up the edit. Oh, and it's a result that must be used. Well, this is a result. We're going to return this out of the function at the end. Oh, and generic edit has to return edit result, which causes an error, but that's okay. We need this and new node. Why? Yes, we need to allocate. No, so we need to have this return a new node, because otherwise we don't know what was created. And we also we allow edit func to change the cursor location, because we're safe in the knowledge that when we still have essentially a copy of the cursor location, the cursor path here, because nodes to clone is just traversal down the path before the edit happened. So edit func could change the cursor location, and then we need to return a result at the end here, just so that everything's happy. Oh yeah, and we require that this return a node. Does... okay, it seems like node doesn't have a type argument, lifetime argument. So we need to reallocate whatever node we had. Then we do the zipping back up the tree. And what are we doing here? Maybe we should allow, because we need to let edit func needs to let us know. Mute edit func. Yes. Don't know how long ago that was, but that's better. Okay. Well, I mean, we get the same errors, but whatever. You know what? We're going to cannibalize this function anyway, so we may as well. No, actually, I think we should copy it past one slot at a time. So we allocate the new node, and then what we're doing now is we're saying, oh yeah, we have an edit. So somewhere in the tree, somewhere in the somewhere either the cursor or the cursor's parent, we do some edit. And what an edit looks like to Sapling is we're removing a node and we're replacing it with another one. That's kind of what an edit is, as far as Sapling is concerned. And that change is not actually a change, it's a replacement. So now the child indices, the child pointers of the parent is invalid, and so we need to change those. We need to clone the parent and then update the child pointers because we replaced one of their children, and then so on and so on and so on until the root. And now we get a new root, which is our new edit. And then we can just leave a load of those. So we don't have some kind of steps above cursor. And I think we need this because we need to know whether or not the edit function actually edited the cursor, like whether it replaced the cursor or the parent. But because we only pass it the cursor and the parent, we require that it edited one of them. So we could just make an enum up here somewhere and make the comment first, and enum to actually what should we call this? No, we don't even need it public. Enum edit location. It's either the cursor or parent. The two possible locations where an edit could cause nodes to be replaced. And let's just derive some stuff. On hash. We can also say, can we do this in Rust, that we say these are oh no, we actually can't, because that doesn't make sense. You can't safely typecast enums into their underlying data type. And let's just make a function on this edit location. No, we don't need this to be public. No, it doesn't even matter because we can't access the enum, let alone its functions. For steps above cursor. usize. And this is just self if cursor, then 0, then parent, then 1. This is just like enough to say how many steps above cursor was the edit made. And obviously this can be inlined at any opportunity. So we'll just hint the compiler that. And let's just say the edit caused the to be replaced. There, and where was that thing? It was generic edit. And so now we require that edit func give us some more information. It also gives us an edit location. And in fact, all of these does it. Ah, that's quite nice. But I still think having it as a function is better because functions, like, it's more readable to see what this is doing. In fact, we could make it more performant by saying cursor is 0. And then just saying self as u8 as usize. Oh, that works. That's very nice. Okay, thanks for that. And in fact, we need to expand edit result here because we only need to know these things in the case of a success. If there was a failure, then we just need to buck out immediately. So I'm fairly sure edit result is just a result. Oh, it's a result between, yeah, edit success and edit error. So if we just jump back to here, then we need to return a result that's either this. So it's either all of the things we want and the edit success, or it's an edit error. Let's just happy with that. Right, so it's not. But we can cheekily exit, and then success, and location. Edit location. And then this becomes edit location dot steps above cursor. And then, yeah, so instead of this, we're going to return OK success. So now we've done the bounds check. In fact, we could just straight up unpack let steps above cursor is edit location dot steps above cursor. Then that just saves us some. Yeah, it saves us some code and it flattens nicely. So now we know that this stuff is valid. We can continue with our editing, and we can actually do the zipping now because we know that. So we know that the zip somewhere in here, or is it? Oh yeah, the zip at the end of this line here. If you zip a longer list with a shorter list, then you lose the information in the longer list. And we want to assert that they're the same length. So that's what the assert up here is doing. This is kind of an explicit assert, but I wanted an assert with a better message than just two things are not equal. So we do this, and then we step up the tree and doing our stuff. And now we do the edit. We should probably... what's this doing? We don't actually need to bother with the history until right at the end. So we should probably put all of the history stuff together. Clean the tree. This is... So allocating node... yeah, actually it doesn't really matter if we allocate some memory and then panic. That's not like... Oh, enum as usize. I'm convinced that this didn't work, but I may have just been wrong. And it'd be very silly of Rust to not let you do. Oh, it works. Wow. Okay, thanks. Right, where are we at? Oh yeah, these are never created, but that's okay. So now we're dealing with the undo. So we, instead of cleaning up the edit, we clone all the parent nodes to get a new root. Always nodes to clone. Aha, so here we don't want to use self.cursor path. Instead, oh, hold on. We need to know the child indices that we're zipping back up, but we can't take them from current cursor path. because that, I think that's the cause of this whole bug in the first place, is that current cursor path is dependent on the cursor location, and that could move during an edit. So assert not equal. I knew you could add a message, but the message can't be formatted. I wanted to say something about because assert doesn't know that the right hand side is a subtraction. It doesn't know what those things were, but I do, and I want that to be explicit. Right. And anyway, this code, I suspect that very little of the code we write right now will actually make it into Sapling later on. I think a lot of this will just be refactored a load of times. At least that's my expectation. We should also probably store this. That this should be a pointer to node, right? Okay, and then if we don't actually need this to be mutable. Nodes to clone and let old cursor path vec. This is going to be a cursor path. Is self dot cursor path dot clone. And we need both of these because we need to know which child indices we have to wire up. We got to. So instead of current cursor path, we want to zip the old cursor path. Okay, so this function doesn't have any errors, but for sure it doesn't do what we want. We can get rid of this. Hold on. I know why the warnings have disappeared, and that's because Rust C, the Rust compiler, has bigger things to worry about right now. So just the easiest thing we can do to check that this is vaguely sane is to update this. So let's just, for the sake of just checking that this works, let's rewrite replace cursor in this style. So replace cursor is, instead of this, it's going to be, let's just put a return, an explicit return at the top. And it's going to be return self.perform. Oh yeah, just generic edit. What a beautifully horribly named function that is. And then as an argument, we want to pass a closure. And the closure takes a new self, which unfortunately we have to underscore. And then what were the other things? It takes the parent cursor. And this has to return an edit result, but that's okay. You know what? This would be much better done as an explicit function if we just say fun do replace. Oh wait, it's underscore self. Yeah. And then parent is an option. Hold on, can we put sanity checks in here? Oh, it looks like we can. hold on, wait. Let's just build and see if... Oh, yeah, okay. So we can... Yeah, actually, yeah, this is probably... I kind of like this more. I don't know, I'm kind of undecided on whether this or self is actually better. Largely because I learnt JavaScript as like my first language back in ye olde times when I learnt. And I got really used to this. So I think I'm just... very biased towards it. Sorry, this as a specifier thing. Okay, right. So this needs to return an edit result. So we can put this in here because we know that the code that gets the cursor is the same as passing the cursor and is an argument. So that's okay. And then the new node is going to be this, which, you know, it is itself fairly broken, but we'll ignore that for now. And now we're onto the whole, like, nodes to clone stuff. We could just get rid of this. What's the new node name? Okay, yeah. So we store the name of the new node, and then return it out of the function. Except that we're not just returning it out of the function, we're returning node. What do we need to... let's just make a mark here so we can return generic edit. What do we want? We want the node, location, and success. So node... and then location, some location, and in fact location is edit location cursor, because we're replacing the cursor with something else. So this is the most intuitive way that an edit could happen. Wait, what? Excuse me. Oh yeah, we just return this. What's... Oh, we copied it all. We put all this code into the if branch. That's why this is not working. Ugh, I need to run the compiler and check. Oh, node is not in scope. Okay, that's new node. Oh, we don't need to call self.finish edit as well. Expected result. Oh, so that easy. Okay. So I think that now this will compile if we just make everything else panic. And comment this code out. Which is really not a good way to write production code, but it's fine. We're going to fix this. Panic comment. I'm sure there's a Vim where I could use macros, but I just don't want to have to learn that right now. Okay. Okay, as expected, we get a lot of warnings. So, fingers crossed this works. I'm very skeptical, but whatever. Ah, there we go. Nice. It doesn't work. Nodes to clone. Ah, so we're getting the whole invalid nodes thing. So yeah, we're getting, which thing was it? 358. We're getting this again. So why is this? No, nodes to clone is the root, and it's false. All right, that makes sense because this. Oh, I wish we had a bracket matching, but I think, yeah. So the first element in the nodes to clone is the root. We expect that, and so this is the whole root, and then the next one is false because that's where the cursor is, and this is kind of what we expect. We expect nodes to clone is a path from the root down to the cursor, and currently there's nothing in between the root and the cursor, so that's just one thing. So this is fine, and then the cursor path has one thing in it with 0 items popped. I think we should arbitrarily just pop an item, I think, because nodes to clone actually starts cloning one step above the cursor. So I think we need to just skip one here. Because that will fix it. I think this will fix it because yeah, I'm pretty sure because we deleted somewhere in our code. Hold on, can I look at the diffs? Let's just make sure that you can see the diffs as well. How big is that? Is that? Oh, that is readable. Okay, I just have the a little display on my second screen, but it's really small. Where's the code that we deleted? So yeah, in replace cursor, somewhere in here. Ah, yes. Okay. So replace cursor popped the last item off the list of nodes to clone anyway. And that makes sense because you don't want to actually clone the cursor because that's silly. The cursor is the thing you edited. And yeah, why would you want to clone something that you just created? Yeah, that doesn't make sense. It would clone and then immediately destroy the old one. And this will always happen because we always want to start zipping one node above where the replacement happened. In this case, it's the cursor, but if the hold on. Oh yeah, you can't see the code. If the edit location, if the edit function told us that it replaced the parent of the cursor, then we should start two up the things to clone. Right, let's. Oh, what? No, stream is not starting soon. What's OBS playing at? Can I understand? Oh. Interesting. Oh, yes, because we should say -1 here, because we're going to skip one. Or we just arbitrarily pop nodes to clone. But I kind of don't like that, actually. As a way. Oh, and also we're checking cursor path, not old cursor path. So that's also some potential bugs. Oh no, exactly the same thing's going to happen. We should say -1. This is a bit hacky. I should probably find a way to make that nicer. Oh my word! That actually worked. That is incredible. I was fully not expecting that to actually work. Wow. That's so nice. When you have code that, like, even though this is obviously not the first time we ran it, but even code running this quickly is not expected usually. What's it complaining about? I need color. This is not used. Yeah, okay, so these are all intentional. That the closure doesn't actually need... It doesn't actually need to edit the thing, and it doesn't need to edit the parent because all we're doing is replacing the cursor. Yeah, this feels so much cleaner as well, to just have a closure and a single edit function. The challenge becomes, will it actually do what we expect it to do? Will it actually help streamlining all of this? And I think even if it doesn't, we've considerably simplified the code. So even if it does exactly what it did before and it still has the bugs, which I really hope it doesn't, then we'll have hopefully done something useful, because the code will just be nicer. What's it saying? Oh yeah, this is a whole load of unused things because we haven't implemented everything yet. It's okay. How far are we into stream? 1 hour 11. Okay. So now we need to do the same thing here. And yeah, so we could actually do the same thing. We could say just return some closure, and we can just copy this line, I think. These 2 lines, in fact. Unreachable code also what? Oh, I understand. The we can comment this out. In fact, all we need to do is to comment this, because the return is actually not causing an error. Unreachable statement, that's okay. And yeah, I get the red compiler error is saying that this closure doesn't return what it expects to. And so we can do the short circuit here, and return an error. That's all fine. And the error changes, but that's okay. This is not needed. So we allocate the new node. That is needed. Let's make sure to clone it into the right place. And we don't even need nodes to clone, I think. Well, we shouldn't need to do this. Cloned cursor is simply the clone of the cursor. I think we don't need to do anything. We don't need to find the cursor now. So this is just cursor.clone. What can we do to get rid of this message? I think we can explicitly panic at the end. Okay. So the name of the new node, we need to just cache this. We may as well just do that straight away. And this is creating the node to insert. Oh yeah, we don't even need the unwrap message anymore, because we're not even unwrapping anything. And then we need to store the right child, the correct child. We could probably just combine all of these. And then if we did everything correctly, then we return OK. And then we can get rid of all these comments. And what are we doing? We're returning cloned cursor, not new node. And then location is edit location cursor again. And then supplied 3 arguments. Oh, yeah, because we're initializing a tuple. What's the problem? Okay, it needs to be this. Which is not defined because of this. Alright, you don't have to cover my screen with a giant thing. Yeah, and the borrowing should be fine because edit self.generic edit, which will change to something more useful later. That does in fact just directly passes control to the closure. So it doesn't really matter if any of if the closure edits stuff and we're borrowing. We can't borrow self inside. We don't borrow self inside generic edit. So this should do exactly the same thing, we hope. What are we doing? Insert child. Haha, it does. That's quite nice, actually. Okay, so this works. Now let's move on to this one. Hopefully, what are we doing? Okay, so let's just do the standard procedure. Oh no, wait, we don't even need to do the return anymore. You can just implicitly return. Okay, so I think we don't need to, I'm not going to bother about the, oh, no, because we get a syntax error, I think I'm going to return. Okay. So we need to do this. So we do need to do this because we're unwrapping, except that we're doing something different. We do need the cursor in this case. Parent. And this is actually, so I think there's something parent dot unwrap or, is this what we want? We want to unwrap to okay. Is it there's like result? Unwrap or this maybe. Pretty much what I want is that we either unwrap and then it returns a value, or we the unwrap fails, we get none, and then we return the error out of the function. Is there map or, and then is the first thing we want to resolve. Okay. Is this, let's just, oh, we don't have a semicolon. Panic. Just so that we get different errors. Oh no. Can't go build. Are there any things in here? No, there aren't. Okay. So it seems that that was okay. If we could, yeah, okay. So now we just start copying code across because we can unwrap parent correctly. Anything? Oh, okay. Let's just ignore the things. I think they. Okay. Aha. Right. I thought you'd know what this does. What to do? Okay, so this is all fine because parent is now defined. Some parent. And then we don't need to generate nodes to clone. That's something we don't need to pop off the end of nodes to clone. We do need to find, we need to know the index of the cursor. I think that just has to be another argument, because that is accessible. Generic edit knows which index of the cursor's parent the cursor is. So let's put it at the end, I think. Cursor index usize. This is going to be a lot of refactoring. That's bit annoying, but okay. I guess we could just put underscore, but I don't really want to. I'd rather be explicit anyway. Where's this? Fun, it takes option use size. Edit func. Where is this? Oh no, because if the cursor is the root, then the cursor's sibling index is not defined. So I think we should, instead of passing the usize here, we should pass it along with the parent. And then we want to map this node, and then we return node packaged with old cursor path dot last mute. Wait, what? Oh, because this is a cursor path, and then we unwrap. Okay. And this is parent and index now. But what was it complaining about before? Again, ampersand mute new size. Oh right, we just dereference. We should probably have a note here that's saying here is safe, because if the cursor does have a parent, then the cursor path must have at least one element, or one element. You have elements of lists. Okay, so now all of our closures will be invalid. Where are they? Nodes to clone. Wait, what? Oh no, let's do them in order. 398 is this one, and we're not even using parent and index, so this is and the usize. No, not IDEX, index. Okay, so that's happy now. This is again not happy, and index. That's now happy. Parent and index. Okay, I think we're back to the same old compiler errors that we had before. Some parent is not defined. Well, why is that? Oh yeah, because it's parent and index, and then we're unwrapping it into parent and index, because we expect them to be correct. Oh, and if they're not, we early return. So this is feeling quite idiomatic, which is quite nice. Let me see what's going on. So now we've got the parent, we can check. Cursor sibling index, we don't even need to do that, because it's already there. Okay, that comment is not necessary anymore. What's going on now? These can just be got rid of. The cloned parent. Okay, so we do need to clone the parent. That needs to come in. Oh, this is a classic copy-paste error. Okay. And we don't have access to nodes.clone, but we can just say parent.copy clone. There we go. The new child node is this. That's okay. Let's just, no, we don't need a comment that says clone the cursor. What's the name of the new node? We don't need to say that this is a child, because it's not even a child. So this is kind of a sibling, actually. Yeah, client parent dot from char, blah, 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 blah. And then we need to insert the child into the new parent. What's going on here? We don't need to edit, but we do want to return the success. I think cursor sibling index. Oh, this is just index. Maybe we should call it cursor sibling index. At least cursor index. Because whilst I'm an advocate of terse code, I think terse to the point of not being readable is not useful. Right. Closure expected 3 arguments, but oh yeah. That should be happy now. And we can remove the implicit thing. Oh, I'll fix that error later. Let's fix this one and hope that the other one gets fixed at the same time. The new node is the cloned parent, and the location is cursor edit location dot parent. Finally using it, and that should be everything. Okay, let's just get Rust to give us a nice error. But why is the question mark not working? Because this is remove error. Oh yes, thanks. Ooh. Cannot borrow self. Oh, we're borrowing self somewhere. It needs to be this. And then this is here as well. Oh yeah, and this is, yeah. And we don't need the cursor, so we can not do that. What's happening now? Yeah, we just need to add a thing to cursor path to let us do this, because pretty much we're not even using the fact that we get a mutable pointer. So last mute needs to be, we need another one that's just like last, and then it's just a pointer. In fact, we might as well just return. We may as well just dereference it and copy. There's no point returning a usize. Can we do that? Oh, lovely. That's so nice. Okay. So now we can just say last. And it should be happy. Type usize can't be dereferenced. That's okay. Oh, I understand. It's because we specified and weren't using the thing. Is Rust happy now? Oh, we get to test our work. What were we even changing this time? We changed replace cursor, changed insert child, and then insert next to cursor. Ah, yeah, so it was insert next to cursor that we were doing. So what's that? That's I. Ooh, lovely. We do like a nice crash. So what's going on? So I think this skip needs to happen outside here. Because I'm pretty sure we need to, that skip is saying start cloning slightly above the cursor, but we've just set this up so that these are guaranteed the same length. I'm pretty sure this is okay. So what do we check now? That we don't even need this. We just need to check that these are the same. I think. Does this work? Because we're because we're cursor. Okay, does it work? That's the main thing. Oops, I was doing that to Vim. Ooh, it works. Okay, and then after an array. Oh, this is okay. So this is quite nice now. Now we have the real beast to fix, I think. What is this? Is this generic edit? Okay. Replace cursor. I'm really enjoying how small these are. Like these used to be just giant beasts of functions with loads of comments, and now they're just like do this, do this, do this, do this, and it's only the stuff that's in the edit. Right, so insert next to cursor has been done. Right, delete cursor needs to be dealt with. So, we could do, oh yeah, we just need to do the classic return. Turn self generic edit. Yeah, it's fine. No, we won't get the right return type. In fact, we just make this panic, and then it doesn't matter what the return type is. Okay, so nodes to clone, we don't even need this. Deleted node name is just the cursor dot. We will need the cursor in this case. Cursor dot display name. That can go. We don't need to unwrap. Yeah, okay. So we need to. Hold on. Why is Rust C not indenting? Oh yeah, I think Vim's auto indent is getting confused. So short circuit if the thing, if we're trying to delete the root. Well, so we'll detect that we're trying to delete the root. It's probably easier to do that just by checking that the parent. So we're going to have to unwrap the parent at some point because we need to clone the parent. So we may as well do the whole unwrapping to get this. So we copy this, and we may as well do this before performing this, because deleted node name does a heap allocation because it returns a string. We have the incorrect comment, so if the parent of the cursor doesn't exist, then the cursor must be root, and we can't delete the root. This is edit dot deleting root. So now we can get rid of that because the short circuit is done for us. Find the index of the cursor. We've already done this. This is cursor index. Cloned parent. Yeah, we probably should say that we cache. Wait, do we even need to? Okay, I'll leave that for the time being. So cloned parent is this. and this is not even this is parent.clone. Done that. Clone parent.delete child. Well, yeah, we deleted it. We should probably say return. No, return the name of. Oh yeah. Name of the cursor before it's deleted, or before it gets deleted. So cloned. We've done the delete child. That's done. Oh, what a beautiful error! Like, how did I write that comment? Cache cache this so that we can. Beautiful. Hold on, maybe I just edited that. Anyway, if that did get into master, then that's just funny. New parent child count. Okay, well I think this is. Move the cursor. Oh yeah, we don't need that because this is causing. This calling, moving the cursor after finishing the edit is what's causing everything to break. Right. So, yeah, this is the whole thing about moving the cursor that was just a complete hack, and I don't think we need to do it anymore. Yeah, so we want the comments to be with the things. I think the comments should be in here, and this can be else if. Let's just join these. It annoys me that the code is underlined the whole time. Okay, so that's just the code that moves everything, and I'm pretty sure it only relies on stuff that's been defined already. So that's okay. We'll get some decent compiler messages soon. We can just get rid of finish edit, we don't need that. And then we move this in here, and don't panic, Mr. Mannering. So we have edited the parent, so we want cloned parent, and then cursor. Oh yeah, edit location.parent. Oh, okay, this is cursor index, just variables that we've renamed. Oh, it's the classic borrowing self. We need to borrow this. Does it really run? Oh, it does. And it actually works. And the crash bug is fixed. We fixed the bug. Oh, and that's everything. So we've rewritten everything as well. That's great. Hello. Cool. We just fixed the bug that we were trying to fix. So.
Oh, cool. You're still webcasting?
I am. Guys, you can see my dad. There's Dad. Dad says hi. Some people might say hi in a bit. There's stream delay, so.
Oh, okay.
Yeah, so this is what I'm streaming right now.
Yeah.
So you can see I'm moving, and then this is what people are seeing right now. So I'm like watching myself here.
Yeah.
So you can see there's massive delay. If I were to like wave, then we can just stop,
cool.
And I'll wave later, again in a few seconds.
Oh yeah.
There we go.
Yeah. Anyway, dinner's ready.
Yes, I'll come down and eat once we've finished this. Okay, right. Fun interruption of parents. So yeah, we should probably just like look at the diff, which you can't see, but that's okay. GitHub desktop. Right. So what have we done? We've added this last thing, which actually, like, I should have just made that. I was just lazy and didn't create it. Do we have we might have some tests for cursor path. I'm pretty sure we do. Do we have last mute? Okay. Do we have a test for this? Do we even need a test for this? We should probably do tests. Oh, you can't see the code. IDE view. Okay, so we want to test fun last. Let's just test last and last mute at the same time. Oop, mute. Okay, so pretty much we a path that's pointing to the root has no last. Let mute path. Assert. Oops. Path dot last. Last should be none. And oops. What? Oh, assert eq. And last mute should be none as well. Right, so we just push something and index, then that should be the last. So let's just say path.push 0, just for the sake of having something, and then assert eq path.last, and this should be sum 0, and last mute, oops, should be sum pointer to 0. Or yeah, dot copied is sum 0. Which, you know, like, I guess we are just, this is just the definition of how last mute works, but whatever. And then if we change the last bit of the path, then last should also change. And this should now be 5. Oops. Yeah, unwrap. Because unwrapping in unit tests is okay. If we, yeah, pop some more and check the last. Oh, I meant push. 3. And then just pop the last thing. And we should get back to having this situation here, because we haven't edited this. So path.pop. We can assert that path.pop is in fact sum 3 as we expect it to be. And then pop to the root. Yes, we want to pop and then assert that it's 5 because that's what we expected it to be. And then now we assert that we're back at the root. There we go. If you just check, this should all succeed. Yeah, okay. It's a bit boring, but got to be done. So we can, I think I'll commit this. Oh, we're still on master. Okay. Git checkout. So I guess we started the stream expecting to refactor the code, but in fact, what we're actually doing is, so we started expecting to remove the crash bug, and what we've actually done is refactored the code. So I think refactor dag edit is a decent name. Oh, I check out as branch. Oh, we can do this from the command line, although it's more visual for you guys to see it from GitHub desktop. So we added last first, so we add cursor path last, and then using that we heavily refactor dags edit methods. And yeah, okay, let's just have a look at the diff for that. I'm pretty sure it's just like we created a edit location, and then yeah, okay.
When you're ready.
Yeah, but are you guys waiting for me?
We were, but that's all right. We can eat.
Yeah, you guys eat, I think.
Okay, cool.
I don't have very much longer. I'm just wrapping things up, but it.
That's
like,
all right. That's fine.
You know, like stuff needs to be correct. Okay, it's apparently dinner time. So yeah, we added some logs, but I think that's just part of the refactoring. Oh yeah, and then it's just massive amounts of stuff has been refactored. So here's the last thing to check before we wrap up, is that has the other bug that we found been fixed? So if we cargo run, the bug that we saw was that if we make an edit and move somewhere, we expected the cursor to go back to, so if we did a replacement, say we replaced this with null, and then we moved the cursor somewhere else, we expected the cursor, when we undo this change, to go back to null rather than the root. Excuse me. Why? Okay, that's going to have to be another bug for another day. I'll file an issue. If someone knows how to fix that, then they can. For the time being, this is, I think, like, fixing the crash bug is the important thing, because like unintuitive behavior, I suppose it's still wrong and undefined and bad, but it's nowhere near as undefined and bad as the editor just crashing if you do a certain combination of edits. That's just like not allowed for text editors. So yeah, I think that's been a productive stream. We've like the code is so much cleaner now. It feels a lot better, and we fixed a bug. So I think that was productive. Hope you all enjoyed watching. Thank you all for coming, and I'll see you guys next week. Bye.